All right, so let's talk through this a little bit. So our 3 different types of studies that we have, we've got a survey, and we actually have participated in a survey recently. When we did our around the room measurement thing, that was a survey. We asked you questions that we are trusting you to be honest on. So an example of a survey, ooh, that's the chunky pen, holy cow. So an example of a survey is the census that we did here. We asked questions. The people in the mall with the clipboard right outside the food court, they're taking a survey. It's asked questions. So the big clue on a survey is asking questions. Experiments are the really easy ones to spot. And after that, it's going to be an observational study. Because a survey, we're just asking. An experiment, I'm not a huge fan of the word manipulate, but it is the honestly best word for what they're doing. Actively choosing if something is happening. You will either get the medicine or you will not get the medicine. You will actively get the theory or you will not get the theory. You will actively, I'm choosing, you get the paper, you don't get the paper. You do get the paper, you don't get the paper. I'm choosing what you do, even if I don't know who you are. So it's actively choosing. An observational study is not being actively controlled. We're just watching what happens. So this one feels kind of like watching. So observational studies will happen a lot with things like school. I can observe that the more homework you do, the higher your grade goes, but I'm not going to say, all right, you're not doing homework because I want to see how far your grade changes. And you're going to do all the homework because I want to see how far your grade changes. I'm not actively choosing how much homework you do. I mean, you're choosing that, but I'm not actively making the choice. So the experimenter is not making the choice. So in an observational study, we're observing, we're watching. I don't get to choose what you do. I can just watch and see what happens. So things like who gets cancer tends to be done as observational studies because no one is going to ethically say, I'm going to give you something that I know causes cancer so that I can do these trials. I want to see how long it takes for exposure to radium, just because I'm pulling from the play, to cause cancer. I'm not going to on purpose expose you to test how long until you get cancer. Okay? That tends to be done as I've noticed this correlation between people who work in asbestos factories and this rise in cancer. That's done as an observational study. I'm not going to say, you must now go work in the factory that we think is causing cancer. That's really unethical. So observational studies are often done in place of unethical experiments because that's just generally frowned upon for that. There's things where they're studying the mortality of cigarettes. They're not going to say, all right, you now got to go smoke. You healthy non-smoker, now got to go smoke a pack a day so we can see what happens to your lungs. Not really ethical. So they do observational studies of people who already make those choices. I don't get to choose a random person. Now you got to go start smoking. Okay, so observational studies, they're not the most scientifically pure way to do it, but we have them because a lot of times the scientifically pure way to do it would be incredibly unethical. We are not causing random people cancer so that I can do drug trials. Okay? So, we're going to look at, and it is not page 48, because I have not updated these page numbers yet. I'm super on top of stuff. Page 88 in your book. We're going to do page, I think just page 88 today. So fix it. Oh, that's the wrong color purple. Page 88. Aside from the handwriting, that looks pretty close on. All right, so we've got here this study of 500 children were randomly selected to receive a new vaccine. So 238 were randomly selected to receive a new vaccine. The other 262 children were randomly selected to receive a placebo. So they were selected. The children and the physicians didn't know which group they'd been assigned. So they had 500 syringes. They don't know which one's an itch, but they were documented and were randomly assigned. After 5 years, we have all this data here. So the first question we have is this an experiment or is this an observational study? An experiment. How do we know that it's an experiment? Actively selected. So selected is going to be our keyword here for that. They were chosen. So this is an experiment. Because they were selected. Selected is our keyword for that. They were selected or chosen or assigned. Even if the doctors don't know, even if the people themselves don't know, it's called a double-blind study, which would be something you learn in science class. We're not going to worry about double-blind versus single-blind. And that is the most pure way to do it. So the doctors can't give them a clue that, oh, you're supposed to be getting the medicine now. So the next thing we're going to look at is what is the variable? It's not going to be the children. The vaccine is definitely a variable. So that's the only variable we've talked about so far. So the thing that's being changed is a variable. Oh, that's not the word I was looking for there. I just said variable. So the vaccine. If they got the vaccine or the placebo. Do you guys know what a placebo is? Placebo is usually fake medicine. It's pretend. So they'll give them a shot of usually just water or like saline water, like normal what they have in shot water, so that it still feels like they got the medicine. Seems like they got the medicine. The doctor thinks they gave a medicine. They think they got the medicine. And sometimes your brain tricks you into thinking it was real medicine. So they call it a placebo because of an original study that happened with, there's a whole lot of scientific papers about it. But all it means is they didn't get any medicine. It's not medicine A versus medicine B. It's medicine versus no medicine. Is this a categorical or quantitative data set? Categorical. They are divided in categories. They either got the vaccine or they got the placebo, split them into two camps. We didn't get like a half vaccine or a quarter vaccine or a 1.5 vaccine. It's not on a sliding scale. This is categorical data. In this second paragraph, where we have all the data that they found in their study, we actually have another variable. I'm going to close this window because it is now getting hot in here, but it smelled like someone dropped a whole bottle of cologne in here last period, so I had to open it. So we have another variable in here somewhere. What's something else they were measuring or noting down? I'm going to make the page a little bit bigger. So look in our sentence with our data here. What else were they paying attention to? How do they know if the medicine worked? What were they measuring? If they got sick. So malaria versus no malaria. So this is the way they're doing studies, and they're doing this in a lot of rural, like continental African countries. If they'll do studies like these on malaria vaccines, because that's where malaria tends to be, just how it evolves. And they'll do these studies in sub-Saharan African countries about malaria versus no malaria. And again, is that going to be categorical or quantitative? Is that a sliding scale, or is that a yes or no? That's going to be categorical. Because again, it's yes or no. It's not, well, they half got malaria. They kind of got it. They got a little bit of it. No one gets a little bit of malaria. You get it or you don't get it. You test positive for it or you don't test positive for it. So what we're going to do, and we're going to do this in the blank space below C in your book, is I want you to build a two-way table with the data that they gave us. So the tables like we used yesterday, and if you need an example of it, look back one page where we had our left hand, right eye, right eye, those guys. See if you can build one using our variables. So we're going to have vaccine placebo on one side and malaria, no malaria on one side of our two-way table. See if you can build your two-way table. Because we're trying to analyze whether or not this vaccine works. So we need to figure out how to analyze the data, which means we need to show the data. So I want you to try and do that. You've got all the information you need in this table, or in this paragraph. Those two lines are what you need to try and build your table. So take a couple of minutes and try and build your table here. Yeah. All right. This is the way I set up my table. I set mine up this way. If you have your positive, negative on the top and vaccine placebo on the side, that's totally fine. What we're wanting to do is we're going to want to fill in these inner values so that we can get our totals as well. I didn't give myself total tables. So how many people that got the vaccine also tested positive for malaria? You should have it in your table. How many people who got the vaccine got malaria? It says in the paragraph, if I go back this page, so of the people who received the vaccine, 22 did, right? Oop, wrong page. So 22 people tested positive of the 238 who got the vaccine. So how many people tested negative for malaria? How many people did not get malaria who did get the vaccine? 216. Yep. So then we're going to fill in the placebo side in the same way. How many people who got the placebo got malaria? 28. Out of the total, 262. So how many people tested negative? 234. So typically we would still have like a total column over here. I don't know why I didn't program myself one here, where we would total everybody up, and we could see that of this study, 50 people got malaria and 450 people did not, for a total number of 500 humans. Actually, 500 children in this particular case. So what we're going to do next, we're going to look at part D here, and we're going to see, very much like we did with the Titanic thing, what is the effectiveness of the vaccine? What percent of people who got the vaccine got malaria versus the placebo? So for our vaccine, we're going to say, I want to know what the percent is. 22 people out of 238. What percent of people who got the vaccine got malaria? Yeah, we got 9% or 9.2, depending on how you want to mark it. How about for the placebo? What percent of people got malaria with the placebo? %. We do the same thing, the 28 over 262. So now an opinion. Is it worth it? Is this vaccine effective? I don't know. It's a matter of opinion, and this is honestly what medicine does a lot, what doctors do a lot, because there aren't really any vaccines that are 100% effective, that take you down to a 0% chance of getting it. They'll lower your chances. It's a matter of opinion as to if 1% is enough. With something that's really deadly, like malaria, that's one of those really deadly ones, maybe it is. If this was for something like the cold, probably not. 1% is not that big of a difference. And then again, it's a matter of how much does it cost. If this vaccine costs $100 to lower your percent by 1%, probably not. If it costs 2 cents, maybe we'll take a 1% reduction of risk. But again, that's a matter of opinion. So with a 1% difference, it's really debatable. 1% difference is totally a matter of opinion. It's a small study. It was only 500 people. When we're talking continental global diseases, a study of 500 people is not much. So this would definitely be enough to say we need to study it more. Maybe it is. Maybe it just doesn't work well in kids. Maybe we didn't have the dosage right. But it's a matter of opinion. You just gotta have data to back it up. 1% might be a matter of life and death for people. If we're talking continental population, 1%, that's gonna be like 100,000 people. Maybe 1 million people, depending on how big the continent is, what country we're talking about, and how far they can disperse it. 1% of a worldwide population of the 7 billion people, that's 700,000 people. We could save the life of 700,000 people, maybe for a penny? Penny shots? $1? What's it worth? So for something life and death, yeah, 1% probably is enough difference. If it's something like the colds, the flu, maybe? Well, flu does get deadly. But 1% is not a huge difference when we're talking something like the cold. Cold doesn't really kill many people. So if it was for a cold, maybe not. But for malaria, maybe yeah. But again, it's a matter of opinion. You just gotta have data to back it up. Okay? So when you're forming opinions, you gotta include the data to back it up. That's why I'm not actually putting if I believe it's effective or not on the screen. You gotta write it. You gotta have your data to back it up. It's good practice for it. Okay? So there is not a new homework tonight. We can do all the way up through homework 6. There's not any new work today. So if you are all caught up with all the things on Canvas, you're good to go. And we got 10 minutes left. If you have not caught up with all the work on Canvas, you got 10 minutes. Do a thing. Come to trick or treat tonight. I will be there. If we could not tell by my very effective Halloween costume. Yep. Both to yes to both.